Hello, today I am going to demonstrate to create a basic device driver in Linux, and load and remove it to operating system kernel. Linux device drivers are written in C programming language. First, I am creating a folder named Works in desktop to keep the driver files, then open the folder. Then open text editor and create a new text file in Works folder, and name it as hello.c. Hello.c is our driver source code file. Type #include linux/module.h. This is where module_init and module_exit are defined. Then type in the next line, #include linux/kernel.h, which contains the macros required for kernel info. Then type in the next line, #include linux/init.h. Init and exit macros are defined in this header file, and these macros serve to free up kernel memory. Then, in the next line, we will write the start function. For that, type static int init, which is the macro to indicate initialization, test_start, the name of function. Parameter for this function is void. Inside this function, we can write initialization codes. Here I am simply putting two print statements. For that, we have to use print_k function. Kern_info is a macro to indicate this message as a kernel information, which can be seen in kernel ring buffer, using dmessage tool. After the print statements, type return 0. Then type in the next line, static void, exit macro, test end as function name, parameters as void. Inside the function, type print_k, kern_info, ends, to show the ending message. Then type module_init, test_start. Module_init tells the kernel what is the entry point to our program, and also only one module_init call for the program we write. Here, test_start is the entry point. Then type module_exit, test_end. Module_exit tells the kernel what is the exit point to our program, and also only one module_exit call for the program. Here, test_end is the exit point. Then type module_license as GPL. Then type module_author as developer. You can put any name here instead of developer. Then type module_description as first device driver. You can put anything here as the details of driver. That's all. Now the code of our driver is completed. Ensure to save the file. Now we have to create a make file in the same directory to compile this code. For that, open a new blank text document and save it as makefile. Here type obj-m:\hello.o to include our object file in kernel modules. Then type $$shell pwd to fetch current working directory path to pwd variable. Then type all:. Then type in the next line, make -c. After that we need to mention the path of kernel build location. For that, open File System, then Lib folder, then Modules folder. Then open our kernel version folder. Then open Build folder, and copy the path. Then paste the location in our make file, after the -c. After that, type $M equals $pwd in brackets. After that, type modules, hello.c. Then type in the next line, clear:. Then in the next line, make -c, then copy the kernel build location and current directory path from above line and paste here, then type clean. That's all. Save the file. Now, we are going to compile our first device driver. For that, open terminal in the source code directory. Then type make. That's all. Now the compilation of our device driver code is started, and it is successfully completed. Here, we can see a hello.ko file, which is our device driver. The extension ko mean kernel object. Now, we need to load this driver into kernel space. We need root permission. For that, log in as superuser. We need to monitor the kernel messages to verify the working of our driver. For that, open a new terminal window, and log in as root user. Then type, watch -n1, D message, vertical bar for piping, tail -5. This will always show the last 5 messages from kernel ring buffer, updated within each 1 second time. Then type, ls to see the files in our directory. Then type, insmod, hello.ko, to load our kernel module in kernel space. Now, we can see the messages from our driver in the kernel ring buffer, which is written in the initialization function. To view the loaded kernel modules, type lsmod in terminal. Here, we can see our hello module. That means our driver is successfully loaded in operating system kernel space. To remove the module from kernel space, type rmmod, hello.ko in terminal. Now, we can see that the exit message in ring buffer. That means the driver is exited from kernel space. This can also be verified by using lsmod. Now the driver is not listed here. This is a simple device driver, having only initialization and exit functions. Thanks for watching. Don't forget to like this video and subscribe my channel.